Okay, let's get started on our lesson today. We are going to be learning a new way on how to solve quadratic functions, and it is called using the quadratic formula. So let's do a little review, a little background information to refresh our memories. So what does it even mean if I say to solve a quadratic function? So hopefully you remember that quadratic functions are parabolas, right? And so it is a parabola and we have x squared in our formula, in our whatever we're using to graph it. So we could have x squared plus 2, x squared plus 3x minus 2, etc. But we always have an x squared. And so when we're solving, it means that we're finding, if you remember, where the parabola crosses the x-axis. So in this case, the parabola crosses 2 times, there's 2 solutions. Okay, and remember, there's 2 other options. So you could have a parabola that only crosses 1 time, and it just sits right on the x-axis. So that has 1 solution. And then we could have a parabola, and it's not that it has no solutions, but it has no real solutions. Okay, so it looks like this. It doesn't cross the x-axis. It does have solutions. It's just imaginary. We haven't got there yet. We'll learn about that later. So this means solving is where does it cross the x-axis? Okay, and so we have learned now 3 ways on how to solve a parabola or solve a quadratic function. So one way was by graphing. So that was the first thing that we did, was that we graphed. Okay, the second way, we just did a big unit on factoring. And so the second way we factored, we learned that we could factor these quadratic functions. We could set the parentheses equal to 0, and then we could find where the x crossed on, or the parabola crossed on the x-axis. A third way we just learned was using the square root method or the radical method, where we had a formula and it was always x squared and something. Okay, so maybe x squared equals 9. We might have had x squared plus 2 equals 11, something like that. Okay, and so that was a third way. The fourth way that we're going to learn is the quadratic formula. This is number 4. So the quadratic formula can actually be used on any type of quadratic function. So before, like when we graphed, like it was great when we graphed when they actually hit one of the points, right? Sometimes we graphed and they were in the middle of points. And so we would just be guesstimating where it actually crossed. And so the quadratic formula can give us an exact, precise decimal place as to where it crosses, where graphing is not the best way to use. Factoring also, we could factor most of them. Remember, there were some that were non-factorable, they were prime, but actually they do have solutions. The quadratic formula can find them. They were just not factorable. It doesn't mean there's no solutions, they were just not factorable. And then lastly, the third method we used, if you noticed, none of these had our bx terms. Remember, a quadratic function is y equals ax squared plus bx plus c. And so when we solved the square root method, that none of those problems that we did had a bx in it. And so you can't use the square root method if there's a bx. You could only use it if you had ax squared plus c. So the quadratic formula can solve all of these types. There's no like conditions that we can't have, where there were conditions on these where we couldn't do certain things. So what the heck is the quadratic formula? So the quadratic formula, it's a massive beast, but it's kind of fun for all of us math nerds in the house that like to actually plug and chug. So here it is, quadratic formula, x equals, definitely want to write this down, negative b plus or minus a big square root. That's why it's in the square root chapter right now. The square root of b squared minus 4ac all over 2a. So this is what the formula looks like. Yes, I know it looks big and beastie and huge, but we're going to do 4 examples to show you that really all it is just a plug and chug. That's it. Identify it, plug and chug, similar to what you've been doing with the distance formula, Pythagorean theorem, a midpoint formula, all of that. Once you find the information, you just plug and you go. Okay, so make sure you write this down because I'm not going to write it down again on the next slides. I'm just going to plug and chug. So let's move on. As I mentioned, we're going to do 4 examples because there are 4 different situations, 4 different cases that could come up when you have a quadratic formula or you have a function that you're trying to solve. Okay, so our first one that I'm going to show you is where you have a perfect square in the radical. So the first three are pretty, I don't want to say easier, but they're probably the easier examples. The last one we're going to do is the one that's going to be a little more complicated for us. So we're going to start out easy and then work our way up. So here's an example of what they will give you. X squared plus 5x plus 6 equals 0. So remember the 0 here, just like with the factoring, it said equal to 0. So we're not worried about this. The first step in our process for this is we need to identify what is A, B, and C. Okay, so A in this situation, remember, is the number that is in front of x squared. So there's a 1 there. Our A is 1. Our B is the number in front of the x, so it's going to be a 5. It's not 5x, it's just 5, the number. And then C is going to be 6. Okay, once we have them identified, now we're going to go plug it into our formula. So again, I'm not going to rewrite the formula, but I'm just going to plug it in. So x equals negative b, so negative 5, plus or minus the square root of b squared. Now I'm going to put my b in parentheses. That'll be very important because when it's negative, you want to make sure that you actually square the negative. So b squared minus 4 times a, which is 1, times c, which is 6. Extend my radical here, all over 2 times a, which is 1. Okay, so now first step, like I said, identify ABC. Second step, plug it in. Third step, get your radical down to one number. So now we're going to do order of operations. In order of operations, we want to get this radical. That's like a big parenthesis for us. So we're going to get this down to one number. So I'm just going to write right above it. So 5 squared gives me 25. Minus 4 times 1 times 6 is 24. So we have 25 minus 24 is 1. So that means my square root is 1. So now if I rewrite this down here, I have negative 5 plus or minus the square root of 1 all over 2 times 1, which is 2. So this one is like an easier one because we actually know the square root of 1. It's just 1. So I'm going to rewrite this as negative 5 plus or minus 1, taking the square root out, all over 2. Now this example is similar to the problems we did where we took the square root and then remember it's plus or minus where we just worked on that. When you take the square root of x, it's plus or minus. So we're going to split this into 2 different problems. So now we're going to do negative 5 plus 1 over 2 and negative 5 minus 1 over 2. And then order of operations, we want to do the top of this fraction first. So that'll be negative 4 over 2, which is negative 2. And then negative 5 minus 1, which is negative 6 over 2. And that gives me a negative 3. Okay, so my 2 solutions are x equals negative 2 and x equals negative 3. And those are the points where the parabola is going to cross the graph. Okay. Okay, so that is example number 1, type 1, where we have a perfect square in the radical. All right, we have 3 more we're going to look at. Let's move on to example number 2. So example number 2 is where we are going to get a 0 inside the radical. This one is one of my favorite ones because it goes pretty fast, pretty simple. Okay, so here's our example we're going to look at. So we have 2x squared minus 14x minus 13 equals 0. Oh, wait, we're going to back that up. I'm sorry, that is not the right example. Let's back it up. Okay, here's our example. We're going to do y equals, sorry about that, x squared minus 4x plus 4. Okay, so in this one, I wanted to show you that we have a y here. It doesn't matter about the y. Remember, the y is 0 in our situation. If it crosses the x-axis, your y is 0. So this is really a 0. So if you ever see that, just change that to a 0 or just pretend the y is a 0. Don't worry about it. We're only concerned about a, b, and c. So our a is 1 here. First step, identify a, b, c. The b is negative 4. And then the c is positive 4. Okay, so plug it into our formula, x equals negative b. So in this case, our b is already negative. So a negative 4 is going to turn into a positive 4. Okay, so positive 4 plus or minus square root of b squared, which is -4, put that in parentheses because you want to make sure that you square the negative sign, minus 4 times a times c, so times 1 times 4. So again, negative b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. Okay, once we plug it in, the next step is get the radical down to one number. So -4 squared is going to be a positive 16. You want to make sure that you put the negative in the parenthesis in making sure that it's squared. And then minus 4 times 1 times 4 is 16. So what happens here is we have 16 minus 16 is 0. The square root of 0 is just 0. So guess what? Our whole part of this fraction cancels out. All we're left with is 4 over 2 times 1, which is 2. And 4 over 2 is 2. So let's think about this. We only have one answer, right? One solution. Our radical canceled out, this plus or minus canceled out. So think about, what does this look like if a parabola only has one solution? And we talked about that at the beginning. So this means that this parabola is only hitting the graph at +2, just one position right here. Okay, so when you have 0 in the radical, everything cancels. You get one solution because that parabola only crosses the x-axis one time. So there's only one solution in this case. Okay, let's move on to example number 3. Also one of my favorites, example number 3, because we don't quite know how to solve this yet, but I want to give you an example to show you what to do and how to write your answer. Again, once we hit imaginary numbers, then we will understand how to do this. So this example we're going to do is 5x to the third, squared, not to the third, plus 3x equals a -1. I'm sorry, it's going to equal, yes, equal a -1. Okay, so then in this situation, remember that just like with factoring, we can't start solving this until we have it equal to 0. So we're going to want to add the 1 over. I just wanted to show this to you in case you see it. We're going to add the 1 over, and so we're going to get 5x squared plus 3x plus 1 equals 0. Okay, so if you see this, move it on over, set it equal to 0, and then go. So now we'll identify A, B, and C. So A is going to be 5. B is going to be 3. And C is going to be 1. Okay, when we plug this in, x equals -b, so -3, plus or minus the square root of b squared, so 3 squared, minus 4 times 5 times 1, 4 times a times c, all over 2 times a. Okay, next step, after you plug it in, get the radical down to one number. So 3 squared is going to give me 9, minus 4 times 5 times 1 is 20. That gives me a -11. So right now, this should be a big red flag. Ding, 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 ding. I have a negative in my square root. That means that there is no real solution. It is not real. So there is a solution. We're not going to write no solution. We're just going to write that it's not real. And you can stop right here because we don't know what to do next. So just write not real in this situation, and we're going to keep it moving. Okay, one more that we're going to show you. So one more. Now this one honestly is the most difficult, most challenging one, because you're going to see that there is not going to be a perfect square in the radical. I wouldn't say that it's super challenging. It's just there's a lot more steps in order to simplify this radical. Okay, so let's get started. Let's take a look at one of these guys. Okay, so our problem is 2x squared minus 14x minus 13. This was the one I accidentally put it as example 2. Okay, so let's start with ABC. So our A is 2. Our B is -14. And then our C is -13. All right, plugging into the formula. we have x equals negative b. So b is already negative. So that means it's going to turn to a positive 14 plus or minus the square root of b squared. So negative 14 squared. Make sure you put it in parentheses when you square it. Minus 4 times 2 times a times c, which is negative 13. All over 2 times a, which is 2. 2 times 2. Okay, got a lot of simplifying to do. So we're going to start with getting that radical down to one number. So negative 14 squared, 14 times 14 is 196. And then minus 4 times 2 times negative 13 is 104, negative 104. So you're going to end up adding them together and you're going to get 300. Okay, so we have the square root of 300. So now what you want to do is just like we've been doing in our other problems is we want to simplify this. Okay, so we're going to simplify this, the square root of 300. I'm going to bring it over here so I can do this. So can we simplify? If we can, great. If we can't, we're just going to leave it. But since we can simplify it, we're going to go ahead and do that. Maybe, hopefully you recognize that 3 and 100 work and that 100 is a perfect square. So I could just automatically take the square root of 100 and bring it out on the outside to have 10 square root of 3. Okay, so hopefully you recognize that, maybe not. So our new radical, or our new answer is going to be 14 plus or minus 10 square root of 3 all over 2 times 2, which is 4. Whew. Okay, so we're almost done. A few more things we need to do. So now, again, if you can't simplify it, you are just going to leave it like you would leave it as 14 plus or minus, let's say it was a square root of 3, square root of 3 over 4, done. If you can simplify it, we simplified it. Now we can simplify this even more, believe it or not, because now we can simplify the whole number fractions. So for example, so this 3 is locked up inside this radical. You cannot touch it. But the 14, the 4, and the 10 can all be simplified. So if they can all be simplified, we want to simplify it more. They can all be divided by 2. And so we want to divide all 3 of those by 2 in order to make this even smaller into its simplest form. If they don't all divide by a number, you can't simplify it. So if you had like 14, 4, and 5, done. But since they all can be divided by 2, we want to go ahead and do that. And so our final answer would be 7 plus or minus the square root of, 5 square root of 3, because I divided the 10 in half, cut it in half, all over 2. So this would be my final simplified answer. Now, I don't want to make things more complicated, but I do want to show you that sometimes they might ask you for the decimal form. And so to do the decimal form, what you could do is you could come back up here to this problem and you would have 14 plus or minus the square root of 300 all over 4. Okay. And what you could do is find the square root of 300 and see if you can't, take the square root of 300 and then solve it from there. I'm not going to go through it right now, but I just wanted to show you that if they did ask you for the decimal answer, you could do that. And then you could split it up into 2 problems and actually find 2 whole numbers. I'm not going to have you worry about that right now. I want you to just focus on the square roots, but we will get to that later. Okay, so last but not least, let's head to our homework. So this last page here, I'm going to give you a second if you want to hit pause and go ahead and copy these down. So these are your 4 problems for homework. Hopefully I did it correctly. I'm looking to have one of each type that we just went through so you can get a practice of recognizing all 4 different scenarios that I just went through with you. All right, good luck. If you have any questions, please email me and let me know if you have any questions.